H2-IGCC was conceived at a time when integrated gasification combined cycle plants were seen as a real opportunity for future power generation. Key challenge with that technology is in the turbo machinery, not in the gasification part of the process, because its efficiency is currently limited by the gas turbine performance. The advantage is, in a sense, is obvious, that you are removing the CO2 through a pre-combustion process, and in doing so your CO2 emissions are dramatically reduced. So the advantage is to the environment. The problem is that you need to maintain the same levels of turbine efficiency that you have with a natural gas plant in order to keep the cost of electricity down. And you have to make sure that turbine machinery is as reliable. That's all the processes, so that's the combustion, the turbine blading, all of the various process steps in the machine are going to be as reliable as they would be when they run on natural gas. And there's a lot of uncertainty there because it hasn't been done. Since the project was carried out, the market opportunities for IGCC are much less apparently than they were. But the research that was carried out in the project is very important in terms of the ability of gas turbines to burn other gases, obviously hydrogen-rich gases, and they can come from other sources as well. You can use pre-combustion capture to remove the CO2 from natural gas. You can use it to remove the CO2 from other waste gas streams. So the technology developments have a wide range of applications, which are probably more likely to see commercialization rather than the original IGCC concept, which the project was about. Materials are fundamental to the operating conditions of the gas turbine. The efficiency of a turbine depends on the high temperature materials that it uses, because the cycle efficiency is much higher when you're operating at high temperatures. So the materials and their durability in service are fundamentally important. With an industrial machine, which has to run for long periods of time, your reliability over many thousands of hours, even months and years, is critically important. So the challenge is to come up with material systems that have that level of reliability to avoid unforeseen shutdowns, because that's costing the utility companies money, and it's obviously adding to the operating costs and making the technology less competitive. It's a perfect networking opportunity for the whole community, and I think that the fact that we get such a diverse range of organisations participating at the conference reflects how valuable it is to all concerned. Not least to me, working at a university where engagement with industry is really a most important element of what we do to justify the types of research we carry out and to ensure we get significant impact from what we do. It's picking everything up from the near-term challenges that the industry currently has through to trying to tackle some of the big questions and the strategic challenges that Europe and the global communities have going forward.